All right, you're watching Chaos to Clarity. I'm meteorologist Bernie Rayno. You can follow me on X, formerly known as Twitter. I'm at AccuRayno. Lots to talk about. We have a Thanksgiving Day storm. We have January cold coming. We have feet of snow downwind of the lakes then. And then I'm worried about an East Coast storm the end of next week. I think there's going to be an opportunity for that. With snow and ice down in the mid-Atlantic, although storm may be well offshore too. But, I talked about this a week ago that I thought there'd be an opportunity the first week of December for an East Coast storm to try to form. We'll see if it happens. I'll show you why. In the meantime, let's talk about the storm that will start everything. And it's off the West Coast as we speak. Let me show you the satellite picture here. And this is the storm that we're tracking, this upper low. Here it is. Off the California coast. I want to say Carolina. California coast. And it's moving in the northern California. Now, what is that storm going to do? Let me give you a little snapshot so you see what we're forecasting here. So this is the time frame here. Wednesday, the storm's in the southern plains. Then it's going to be moving toward Virginia and then off the coast Thursday night. Now, a couple of scenarios. It could be a little weaker and it stays flat. Then there's not as much snow, or the system could start to strengthen and hug the coast a little bit. In which case, then we'd be looking at an area of over 6 inches of snow. I could see that across interior sections, mostly New England, but even the southern tier of Pennsylvania and northern New York State, and even parts of the Midwest could be a little snow with this. So, this is going to be a little tricky storm as we move forward here. The one thing I will tell you this is regardless of exactly what this storm does, regardless of it, this is going to end up producing a lot, and I mean a lot of cold air here. I want to show you this graphic as we go forward here. This is what I'm calling waves of cold that'll be coming down. The first wave begins over the weekend, right? Watch this cold air come down as we get into Thursday and Friday, and then it comes all the way down the chute into the southeast as we head toward early next week. This is the real deal cold air, by the way. In fact, I think Tuesday morning, your freezing line is going to go all the way down to I-10. You're probably going to be into the 20s in cities like Atlanta. I bet Birmingham and Montgomery are going to get awfully cold with this. January cold, that's what we're looking at. And there's going to be feet of snow in the lake effect bands area. I think a couple of areas to watch would be south of Buffalo and between Syracuse and Watertown in the Tug. 1 to 3, 2 to 4 feet of snow with this, with blowing snow whiteouts. This is going to be a significant amount of snow. Also, we're going to get heavy amounts of snow in the western Michigan and also into the upper peninsula of Michigan. So this is going to be a big lake effect snow machine. Really the first significant lake snow, widespread lake snow that we've seen, because this is certainly going to be a ton of cold air. Now, I want to get to the Thanksgiving Day storm because that one's going to be a little tricky here. Let me take you to the modeling on this. I want to show you what I'm looking at and what I am thinking about when I'm making this forecast. First of all, this is the energy. There's an old rule of thumb in the forecasting world. It's what I call the old Norm Macdonald rule. Norm Macdonald was a famous Southern New England meteorologist on air. He worked here when I first got here in 1990, and he was I think it was in Providence and in the Boston area. And a lot of people that are old enough will remember the name Norm Macdonald. It's his rule that he told me about. And keep in mind, when meteorologists were forecasting back in the 60s, and even the 70s, they didn't have the tools we had, so they had to come up with some ingenious tools. This is one that he told me about. That is, where the energy comes along the west coast, it exits along the east coast. So if you have a storm that comes in, let's say in Los Angeles, let's say in here, it'll probably enter off the Carolina coast. If it's Northern California, it's somewhere along the mid-Atlantic coast or southern New Jersey. That's the idea of it. And it gives you an idea of where this storm is going to track. Now, early modeling, especially the American modeling, had this storm going off the Carolina coast. The European has always been farther north. And right now, all modeling is going toward the European. That is a little farther north, a storm that will go across the mid-Atlantic. And I do believe that that's going to be the right solution. The question is the strength of the storm, right? Stronger storm, there will be more snow on the northern end. A weaker storm, there would be less. So that's what we're trying to figure out right now. Now, I want to show you all the players with this. Let me go to 7 a.m. Wednesday morning. All right, we're going to show you the American model and the European. These are the players in this forecast. 1, 2, 3. How these interact with each other will define the strength and where this storm is going. That's the key. I'll show you the difference in the modeling here. This is the European model. This is the American model. European, not much difference, right? They have this trough in the same place. They have this piece in the same place. And they have this piece in the same place. Doesn't matter, no matter where you look. There it is, 7 a.m. Wednesday. All right, here's where you start to get some divergence here. 7 o'clock Wednesday evening. Look at the difference. There's the European. There's the American model. European, American model. European, American model. Now, the American model, what it's doing is taking this piece and moving it away. So what ends up happening is because this is slower, this isn't going to drop into it. So immediately that tells me the GFS is going to be weaker with this piece of energy. That eventually, why do I care about? This is what the storm's going to do. This is the storm. Think of that piece as the storm, right? This is the guiding piece. So there it is. That's the American. Look at the European model, a little different. American, European. See what's going on? See, the European, number one, is going to take this northern piece and drop it in. So this is going to be stronger. Now, it's dropping it in because the European's faster with it. It's a much faster flow. Look at the difference. There's the European, there's the GFS. Look at the difference. European GFS. The other thing to notice is this upper low in here. Let me go back. I don't know why I did that. 7 p.m. weather. There's also a difference. 7 p.m. Wednesday, sorry. There's also a difference with this upper low right here. The European is starting to take it back a little bit here. Watch the difference. European, GFS. European, GFS. See how the European's a little farther west with it. Now, 7 a.m. Thursday, European. All right. Couple of things here. 7 a.m. European, GFS. Look at the difference. European, GFS. Number one, this piece of energy is slower and it's awfully strung out. Look how it's strung out. It's almost like it's being ripped apart. Here's what happened. You didn't have any piece of energy that dropped into it. So instead of strengthening it, this northern piece is kind of causing it to stretch out like a rubber band. You see the difference? Now, look at the European. Much different. A consolidated piece of energy that's also being enhanced by this upper low, which has come on west and dropped additional energy in it. Look at the difference in the energy here. Look at this wind speed here. Look at this dark yellow and red. And instead of it being stretched out, it's a consolidated piece. This is Thursday morning. There's the European. Look at the GFS. And you'll notice the differences here and here with these pieces. There's the European. Here's the GFS. Watch the difference. See? Note the difference? All of this energy is way back here, and look at this upper lows in here. So there's no enhancement coming into this piece of energy from the upper low on the American model, but it is on the European model. And that's the difference. Right there, that's the difference in the storm. That's what I'm trying to figure out, which is correct. I know there's going to be a storm that's going to take a track, across the mid-Atlantic states like this. It's going to come like this. I know the track, if it's going to be somewhere like this, energy came in here, it'll exit here, so you're going to get a storm track here. But the European is stronger with it. The American model is weaker with it. And I can show you the difference on, this was the upper air. Let me show you the surface. I think you'll have a better idea about the surface with this. Now, let's take a look at it. And I think you'll be able to understand a little better. So, let me get rid of the Canadian. We don't need that. So this, remember, Here's Thursday morning. European, GFS. European, GFS. European, look at the strength of the storm, 1,000 millibars. Farther north, because it's stronger, here's a GFS, 1,005 farther south. 7 p.m. Thursday, European 996, GFS, where is it? 1,004 here. It is interesting that both modeling has a storm in about the same place, but because the GFS is more strung out, instead of one consolidated storm, it has one here and one has one here. You see that? It mimicked the upper air. Meanwhile, the Europeans, no, this is the storm. Now, we had a fresh injection of cold air, not real cold, but cold air coming in out ahead of this. So it starts thumping snow here on the European from the southern tier of New York, Pennsylvania, New York border, across interior sections of New England. That's what the European has. And you can see it. See, look at that. Look at the difference. Goes to a 984 low, the European, Friday morning in the Gulf of Maine. And the GFS, what storm? 1,003. Doesn't take advantage of the cold air. It's just a weak storm. Eventually it gets going, but it's up over Nova Scotia. By that time, the European has it at 983, and the American model has it at 986. That's the difference in the modeling. So the question is, what's right? What's right? I'm skeptical about the American model. I don't think it's handling that southern piece of energy enough. I think it's weakening it too much. I think the European is going to be a better solution. Now, do I believe that the European is exactly right with this? Because if you take the European lock, stock, and barrel, you're looking at a big area of snow across New England. But I do think the European model is better with this. Better. I think you are going to get some snow. I think the heaviest snow is going to be across New England. I don't think it's going to snow Boston, New York City, Providence, Hartford, Philadelphia. You're not in the snow along the 95. I know you guys are tired of hearing of that, but early in the season, it's hard to get the snow until you get the cold air locked in. All right? So let me show you what I think you're going to see for a snow map here. This is the area of snow that I thought we were going to get here as we get into Wednesday night. So I think a lot of this is like, a coating to an inch or two of snow, something like that. And then once you get into New York State, you're talking about a few inches. And this is where you could have several inches of snow. So this is a few inches here. This is like a coating to an inch or two. And then this is several inches of snow. So what I'm trying to do is I'm not taking the European lock, stock, and barrel, because if I took the European lock, stock, and barrel, I mean, your snow area would be like this. Your snow area would be like this. And, you'd probably be talking about 1 to 3, 3 to 6, and 6 to 12 if you took the European lock, stock, and barrel. I'm not going to do that right now. I'm going to thin the snow out a little bit, keep it in a smaller area. That this area in here is probably a coating to an inch or two. Maybe it's a little bigger. You might get some snow down in here towards State College, Wilkes-Barre, Scranton, but it doesn't accumulate. So what I'm trying to do is narrowing the snow band here across the Midwest. I'm trying to turn the right pen on. That this would be like a coating to 2 inches. This would be, 1 to 3, right? And then your 3 to 6 area would be up here. Now, could it be more than this? Absolutely, if the European verifies. But that's the area that I'm thinking about right now. Now this, let me give you the time frame on it. This area in here would be, probably Wednesday night, Thursday. This would be Thursday night in here. All right. So bigger amounts of snow, the farther north you go. Now, behind this, it's just going to get brutally cold here. I want to go back to something here quick. Let me see if I could get back to this here. I'm already out of it. I want to show you, so brutally cold air is coming. as we get into next week. I mean, you could just see this no matter what you look at here. So this is early next week. Look at this deep trough across the Northeast. Monday, Tuesday. Here comes another shot of cold air as we get in the middle part of the week. And then, and I talked about this last week, at some point, with all of this cold air in place, you're going to get an attempt for an East Coast storm. I want to show you why. I want to show you the surface map here as we get into next week. Let me see if I have that. I do. So as we get into Thursday, what's going on here? As we get into the week, Thursday into Friday, you have a frontal boundary stuck in here. So you have a front in here. So all you need is a storm to form along this boundary and you're off to the races. And boy, look at all of this cold air that's in place. The question is, there's going to be a storm that forms somewhere across the southeast. I'm talking anywhere between December 7th through the 10th. The question is where does it go? All right. Does it go offshore or come off the coast? And both are possible. But I want to show you the upper air pattern, and you could see what I'm talking about here. That by the time you watch this, as you get into this time frame, right in here, you're trying to build right in here. You see how you're digging that trough? The GFS doesn't have anything right now, it's a little later, but you see how you're digging this trough. All you would need to do is some of this energy to get out ahead of this dip in the jet stream, and what you would end up getting is a storm that comes up like this. And then you've got cold air in place, and it just snows. Now, if this piece of energy lags behind, then guess what happens? You get a storm, and it just goes out to sea, and nothing happens. But I do think there's a time frame from the 7th through the 10th. That's the European. Let me show you the GFS. It's a little different, but it has it a little later right in here. You see that? It has it on the 10th. Here's your dip in the jet stream. Here's your energy, and something tries to come up the coast. So I think we have to be very cognizant of that toward the 7th to the 10th of December. So that is the first, I believe, is so that we're talking about next weekend, not this weekend, but next weekend into the following week. So between December 7th and the 10th, there's going to be an attempt for a snow and ice event across the mid-Atlantic and Northeast. Now, because you've got the reservoir of cold air in place, and then all you need is this digging trough, something to come out ahead of it. You're going to have a split flow. Something comes in the southern branch out ahead of this piece. That guides it up the coast. You've got cold air in place, and voila, all of a sudden, you have a snow and ice event from the mid-Atlantic to the Northeast, and it could be right to the major cities, Washington, D.C., Philadelphia, New York City. Now, I am not saying it's going to happen. It could easily be offshore, but if we're going to get a snow event in the mid-Atlantic and Northeast, I don't think it happens until then, December 7th to the 10th. Let's see if that works out, but we're going to take a look at this every day. And I'll post updates on X, formerly known as Twitter, as we keep an eye on this. But this is something I've been waiting for in this area. And there's an opportunity coming from the 7th to the 10th. In the meantime, let's get ready. Let's get ready for this storm, your Thanksgiving Day storm. Again, here it is as we get into Thanksgiving, and let's see how far that snow gets and how much falls. I think it's mostly going to be in New England. The I-95 corridor, it's just going to be wet. Questions, comments, you can follow me on X, formerly known as Twitter. I'm at AccuWeather.